A colorful morning to one and all. Right. In the last class, we have discussed about acceleration. In today's class also, we are going to just recall what is acceleration, and then we are going to move to next topic. Acceleration means it is denoted by the letter A. Acceleration equal to change in velocity upon time. Change in velocity upon time. What is change in velocity? Means, for example, let us consider this is a car which is moving at 10 meter per second. Next, after 2 seconds, its velocity is increased and it is moving with 20 meter per second. Here, the velocity is changed from 10 meter per second to 20 meter per second. This gives change in velocity. So, change in velocity. This starting velocity is considered as initial velocity. Ending velocity is considered as final velocity. Final velocity minus initial velocity gives us change in velocity. So, final velocity is represented by the letter V. Initial velocity is represented by the letter U. So, here 2 seconds, it is T. Therefore, A equal to change in velocity V minus U by T. This is the formula for acceleration. Now, the unit for acceleration is meter per second square. When you come to the direction for acceleration, it will be always in the direction of acceleration. Always it will be in the direction of velocity. So, acceleration equal to change in velocity by time. Here, if you observe, initial velocity is 10 meter per second. Final velocity is 20 meter per second. Final velocity is greater than initial velocity. Then the body possesses what type of acceleration? Positive acceleration. When final velocity is greater than initial velocity, the body possesses positive acceleration. In the same way, for example, let us consider a car moving with 20 meter per second. Suddenly, the driver observes a boy on the road. He applies brake. When he applies brake, the car comes to rest. Rest means 0. Velocity is 0 meter per second. Here final velocity is V. Initial velocity is U. Here final velocity is less than initial velocity. Then the body possesses negative acceleration. Negative acceleration. Or sometimes it is also known as retardation or deacceleration. So, this is the topic what we have discussed in the last class. Now, we are going to do a numerical on this problem. Body which is moving with 36 km per hour changes to 108 km per hour in 4 seconds. So, a body starting velocity is 36 km per hour changes to 108 km per hour in 4 seconds. Calculate acceleration in meter per second square. Remember this. It is, here we want to calculate acceleration in meter per second square. So, here the velocity is given in kilometer per hour. Here also the velocity is given in kilometer per hour. First, we want to convert this velocity kilometer per hour into meter per second. So, in the last class, we have seen how to convert kilometer per hour to meter per second. So, 36 kilometer per hour. Now, we want to convert into meter per second. That is 36 into 5 by 18 meter per second. So, 18 ones, 18 twos, 2 into 5, 10 meter per second. In the same way, This is initial velocity. This is initial velocity. In the same way, we are going to calculate final velocity in terms of meter per second. So 108 kilometer per hour equal to 108 into 5 by 18 meter per second. So 18 ones, 18 6. 6 into 5, 30 meter per second. So this is final velocity. This is initial velocity and final velocity. So initial velocity is represented by the letter U. Final velocity is represented by the letter V. Now we want acceleration. What is the formula for acceleration? Acceleration equal to change in velocity by time. That is V minus U by T. A equal to V, that is 30 minus U 10 by T. It has taken 4 seconds to travel, that is 4. A equal to 30 minus 10, that is 20. 20 by 4, 4 ones, 4 5. So acceleration equal to 5 meter per second square. This is the method to calculate acceleration for a given body. In the last class, we said that there are 2 types of acceleration, that is positive acceleration, negative acceleration. In the same way, there is one more acceleration, that is uniform acceleration or constant acceleration. So what is uniform acceleration or constant acceleration? That we are going to see. So coming to the uniform acceleration. For a body at point A, let the velocity is 10 meter per second. After 2 seconds, it has reached to B with velocity 25 meter per second. After another 2 seconds, it has reached to point C with velocity 40 meter per second. Now, if you calculate the acceleration between these 2 points, so acceleration is final velocity minus initial velocity by 2. So that is final velocity 25 minus initial velocity, that is 10 by time, that is 2. 25 minus 10, that is, what is the value? 15. 15 by 2, that is 7.5 meter per second square. Here, if you calculate the acceleration between these 2 points, that is B and C. Here the B becomes initial point and C becomes final point. So initial velocity 25 meter per second, final velocity 40 meter per second. So here final velocity, that is 40 minus initial velocity, that is 25 by 2. So 40 minus 25, that is, what is the value? 15. 15 by 2, that is 7.5 meter per second square. Here acceleration is 7.5 meter per second square. Here also the acceleration is 7.5 meter per second square. Then the body is said to be moving with the uniform acceleration or constant acceleration. When the body is moving with uniform acceleration or constant acceleration, for that body it possesses some kinematic equations. That is kinematic equations. Here we have given kinematic equation, that is V equal to U plus AT, S equal to ut plus half AT square, V square equal to U square plus 2AS. This is old method of representing the kinematic equation. Here first we want to know the terms in this equation. Here V represents final velocity, U represents initial velocity, A represents acceleration and T represents time. One more unknown factor will be S. Here S represents displacement or distance, not speed. S represent displacement or distance. So all the other terms already we have discussed. So this kinematic equation is applicable only when the body is moving with uniform acceleration. So this is the new method to represent of kinematic equations. That is Vf equal to Vi plus At. Here Vi represents initial velocity, Vf represents final velocity, A represents acceleration, T represents time, and S represents displacement. So what is the use of this kinematic equations? Why we want to use the kinematic equations? In order to describe the motion of a body completely, we said that some parameters are required. What are the parameters? That is distance, displacement, speed, velocity, and acceleration. So these are the parameters required for a body to describe completely. In some numericals, they may give some data. That means they give some values, that is displacement, speed, velocity. But they ask to calculate the acceleration. In that situation, we require this kinematic equations. We are going to see an example. For example, I have released a body. So it touches the ground. So with what velocity it is going to touch the ground, and with what time, for how much time it takes to touch the ground. So that in order to calculate that velocity, time taken, height, we are going to use the kinematic equations. Here, when a body is thrown upwards, there will be two types of motion for the body. That is upward motion and downward motion. So upward motion and downward. For example, if you throw a body, the body moves like this and reaches some height. Once again, it comes back. So this is upward motion and this is downward motion. So for downward motion and upward motion, we want to consider some parameters. For example, downward motion. Let us consider downward. When we release the body from the top, there the initial velocity of the body will be 0. Remember this. For a downward motion body or freely falling body, the velocity will be 0. Okay. And when it touches the ground, the velocity will be greater than 0. Remember this. This velocity is known as final velocity. So the final velocity will be greater than 0 and initial velocity will be 0, u equal to 0. And we should take the acceleration a equal to 10 meter per second square. So 10 meter per second square only for downward motion. For upward motion, the initial velocity will be greater than 0. Remember this. Here the initial velocity will be 0 and final velocity will be greater than 0. Here the initial velocity will be greater than 0 and acceleration a equal to minus 10 meter per second square. And final velocity v will be 0. If you remember these three parameters or three conditions for freely falling body and for vertically projected body, we can do the numericals very easily. Be careful, when a body is falling freely, we should remember that initial velocity is 0 and a should be taken as 10 meter per second square. If he has given take a equal to 9.8, then we want to take a equal to 9.8. Unless he does not use, now you want to take a equal to 10 meter per second square and v is greater than 0. Here when a body moves upwards, u initial velocity is greater than 0, acceleration minus 10 meter per second square and v equal to 0. Now here we may have some doubt. Why for downward motion, we want to take a equal to plus 10, and for upward motion, why we want to take a equal to minus 10. That we are going to clarify. So, when a body is falling freely like this, we said that initial velocity u equal to 0 and final velocity v is greater than 0. That means here the velocity is increasing. Why the velocity of the body increases means no doubt gravity. The gravity force is going to act on the body. So the velocity increases. Here the direction of the body and the gravity force are in same direction. So we are going to take A as positive. Why we are going to take A as positive? Because here body motion is in downward direction, whereas the gravity force, the earth gravity force is also in downward direction. Here both directions are same. So we have taken positive 10. When a body is thrown upwards, we said that for a body thrown upwards, u is greater than 0 and final velocity v equal to 0. So that means here this indicates the velocity decreases. Why the velocity decreases? Because this is also the reason is gravity. The gravity acts. But why the velocity decreases means the gravity force will be in downward direction, whereas the motion of the body is in upward direction. Here directions are opposite. So we are going to take A as minus 10. So if you remember this, we can do the problems very easily. So in today's class, we are going to see just one numerical about this kinematic equations. After that, in next class, we are going to do some more numericals basing upon this kinematic equations. Remember students, very important thing, if you are familiar, if you are well in these equations, we can do the numericals very easily. So don't get fear while doing the numericals, because physics means power. So in order to get that power, we want to do numericals. In competitive exams, most of the bits are going to based on the numericals only. Theory questions will be very less. So from the childhood, try to do the numericals very carefully. Don't hesitate to do the numericals. Be interested in doing the numericals. In today's class, just we are going to see one numerical and we are going to stop today's class, and in next class we are going to see some more numericals. Right. So we are going to do a small numerical basing upon the kinematic equation. For example, a body is released. It touches the ground 2 seconds after release. Now calculate the final velocity of the body. So in that case, we are going to use the first equation. So y means here time is given and acceleration is given. Means a equal to, when a body is freely falling, we already said that we want to take 10, and u we already know, for a freely falling body u equal to 0. So we are going to use the first equation. So u for a freely falling body 0, a 10 meter per second square, t it is said that 2 seconds. Now we want to calculate the velocity when it touches the ground. So v equal to u plus at, v u 0 plus a 10, t 2, 10 into 2. So v equal to 0 plus 10 into 2, 20. 20 plus 0, that is 20. 20 meter per second. Remember this, it is going to touch the ground with a velocity of 20 meter per second. In the same way, if we ask calculate the velocity at 1 second, so 2 seconds it reaches the ground. Now we are going to calculate what is the velocity of the body at 1 second. Simply we are going to replace t equal to 1 second. Simple. V equal to u plus at. So v equal to u. What is the value? 0. A, no doubt, it is 10 into 1. So v equal to 0 plus 10 into 1, 10. 10 plus 0, 10. So 10 meter per second. Here, if you remember this, at time equal to 1 second, velocity is 10 meter per second. At time t equal to 2 seconds, the velocity is 20 meter per second. That means for a freely falling body, as the time increases, the velocity also increases. We already said that the reason is due to gravity force. So in this way, if you know the kinematic equations, we can easily solve the problems. So some more problems or numericals we are going to discuss in the next class. Until then, have a good day.